Today on Basic Bytes, a new software release from yours truly for the Commodore 64, 128, VIC-20, and 264 series. The README text file reader, or RTFR, is not just another sequential text file viewer. I wrote it so that I, and you, can include a README.TXT on distribution disks, and the end user can quickly view it by simply loading and running README, with proper word wrapping, pausing between screens, and option to print a hard copy. Greetings, it's JC at Basic Bytes. Today I am pleased to announce the initial release of a small freeware utility for the C64 and 3 other Commodore 8-bit computers called the README Text File Reader, or RTFR. That acronym is a not-so-subtle joke. If you've worked around computers for any length of time, you are already well aware of what RTFM stands for. Well, we aren't dealing with manuals today, but if you go through the trouble of including a README on a disk, your hope is that the user will actually RTFR. As mentioned in the intro, this program is meant to facilitate the end user doing exactly that simply by loading README, which I will demonstrate right now. Most of this video will be captured from my Commodore 64C, but towards the end, I will jump into an emulator to also show you what it looks like on the Commodore 128, the VIC-20, and the 264 series, along with the minor differences that exist on those machines. Assuming that you have a 1541 fast loader because you don't like watching paint dry, this software loads up in just a few seconds. Then it searches for a file on disk called README.TXT, and upon presumably finding it, opens it up and begins listing out its contents to the screen with proper word wrapping and pausing in between screens, regardless of what the screen size of your particular computer model is. This is the README.TXT file that I have included on the disk along with RTFR, which essentially explains what the software is and how to use it. Don't worry about trying to read it all right now, I'm simply going to page through it as a demonstration of how the software works. At the bottom of each screen of text, you'll get a status bar wherein you can press M for more or Q to quit. You can also press the space bar for more, even though that isn't explicitly stated. One thing in common across all the versions is that it fills a screen with text in about 5 seconds. About 2 out of those 5 seconds represent the sequential transfer speed of the 1541 disk drive. Therefore, all of the actual processing that looks at the file byte by byte, determining where the word wrapping should be, and even filtering out invalid characters such as control codes and such that would simply break things, happens in the other 3 seconds. Now that's not at all bad for a program written in BASIC version 2. It is compiled because the interpreter is nowhere near fast enough to do what you are seeing, but the source code is a single BASIC program written on my Commodore 64C, and that's why it supports 4 computers instead of just 1. In fact, my most recent video on detecting screen size and using kernel routines from BASIC pretty well explains how I made this program cross-platform compatible, notwithstanding that I had to find a different compiler for each of the 4 machines. If you are interested in the programming side of things, I highly recommend checking out that video after this one. In any case, once you reach the end of the file, you can no longer simply advance, and you are presented with a different status bar which gives you the options to quit to BASIC, restart reading the file from the beginning, or to print. I have included within RTFR the logic to make a hard copy to any CBM-compatible printer, which also works with the emulated printer in VICE. Therefore, rather than rigging up a camcorder on my dot matrix printer, I will demonstrate the print functionality a little later when we are working in an emulator on one of the other versions. For now, we will simply hit Q to quit. So let's take a look at the contents of the RTFR version 1.00 disk image, which is now available for download, and I will show you how easy it is to use this software on your own disks. Within the D64 file, there are 4 RTFR binaries for the Commodore 64, the Commodore 128, the VIC-20, and the 264 series. There is a 5th program file called README, which is a short loader written in BASIC, which serves no function other than to detect what machine it is running on, and then run the appropriate RTFR binary. Let me be clear that you only need a file copier to copy all 5 of these files if, and only if, you are making another universal disk such as this one, which is intended to run on all the supported machine types. If you are making a disk that is just targeted towards one particular model of computer, which is the case with the overwhelming majority of disks, then all you need is one file, and in this instance a file copier is not required. For example, if I am making a disk for the Commodore 64, then what I will do is load the appropriate binary for the Commodore 64, which is RTFR 64. Once I have that loaded in memory, I will insert my blank destination disk into my disk drive, which I will do right now. Having done that, I will save that file to the disk, but not under its present name. I will save it simply as README. We now have a blank disk with our README program on it, and all we need to do is add our README.TXT file. I'll show you one easy method of doing that in a moment in the event that you don't already have your own. While we're on the subject of the distribution disk, I will briefly show you the contents of the small README basic loader because there's one more scenario I'd like to cover, and that is that you can, of course, choose to support just a subset of the machines. For example, if you just want RTFR 64 and 128 for a disk that is targeted just at those 2 machines. In that case, I highly recommend that you edit this program. You'll notice that between lines 3 and 1000, there is this block of code which has lines 20, 64, 128, and 264, which conveniently corresponds to the machine type detected by each one of these 4 lines of code. If you are making a disk that supports multiple machines, but you are not supporting all 4, then I strongly recommend editing this file to delete the lines which detect the machines that you are not supporting. That way, if the user tries to load your disk on one of the unsupported machines, the program will very cleanly exit with an unknown machine type message rather than return a file not found error. Now that we have the RTFR software on our disk, we simply need to make a README.TXT file, which is not at all difficult on original hardware. Much of my motivation in writing this software came from the idea that the README file should be on the disk itself, as opposed to, say, a text file that is created in Windows and then zipped up alongside the D64. In which case, it will inevitably become lost down the line when someone passes along the disk image to someone else. As a standard, the software does require that your text file is named README.TXT. It should be a plain text file, which means that it contains only visible PETSCII characters and carriage returns, notwithstanding the fact that RTFR actually does analyze each byte and strip out any invalid characters, such as control codes and such that would simply mess up the screen. However, if they are in the file, it's going to take longer for the software to process. Many of the numerous word processors available for the Commodore 64 have a compatible option to save as plain text. This is often listed as save as ASCII or save as text, or sometimes can even be found with the print settings as print to file. Where things get a little more interesting is that the file type of your README.TXT file can be sequential, user, or program according to your preference. RTFR will auto-detect which file type exists on the disk and load that file. Further to that, if you have a PRG-type text file, RTFR will discard the first 2 bytes of that file, since the first 2 bytes of a valid PRG file are supposed to contain the PRG's load address, which we obviously don't want to display on the screen. The reason why I coded in this extra functionality is that this makes RTFR 100% compatible with the PRG-type text files saved by the Notepad feature in the Final Cartridge 3. Don't program without it. So if you already have your favorite word processor with which to create your text file, that's fantastic. But for purposes of this video, we're going to jump straight into the Final Cartridge 3's Notepad because it's just about the easiest thing that you can use if you haven't before. First, we will invoke the desktop, and then we will go over to Project and select Notepad. The one setting I usually change here is the character spacing, which is on space 1 by default, but I change it to space 2. You who are looking at an S-video capture are seeing a very sharp image right now. However, on my CRT monitor, I find that the default character spacing is just a little bit too squished together. The Final Cartridge 3's Notepad is purely a plain text editor, and to be honest, it isn't a great one because there is no copying, cutting, and pasting, so if you want to move a sentence or a paragraph, you do need to retype it. So, if you are including a text file that is of the length of the one that comes on the distribution disk, you may indeed want to look into using a word processor for that. But if your README.TXT is simply a screen or 2 of information, the Notepad is a very quick and easy way to arrive at your destination. So for purposes of the demonstration, we will have my awesome text file. To load this software, type the infamous lodestar, 8, 1. Big surprise there, huh? And please subscribe to Basic Bytes. And now we simply go over to the project menu and save our file as, you guessed it, readme.txt. And that should be all we need. Once again back in BASIC, we now have both README and README.TXT. If we simply load README and run it, lo and behold, we have included documentation on our disk. And with that, I think it's time to see what this software looks like on some of the other machine types. I will be demonstrating RTFR on the other 3 machine types that it supports using VIC. I do actually own a Commodore 128, but I have no effective means of capturing from its 80-column video output, and therefore, VIC it is. We'll begin with the Commodore 264 series, which has been compiled with Ostro Simple. This is the Commodore C16, which is the most underpowered machine in that series, noting that it starts up with only about 12K of RAM available. Nonetheless, RTFR will work just fine. Its 1551 disk drive is a little snappier than the 1541, but not as fast as the 1541 with a fast loader, therefore you can expect loading the program to take a few seconds longer. Upon loading, it displays the text file much as you've already seen on the C64 and would expect. It's interesting to think that if you would have asked me a month ago if I would have ever conceived of releasing a piece of software for the 264 series, I would have said no, as these machines are essentially not on my radar. However, after releasing my last video about detecting screen size and using kernel routines from BASIC, I received several questions on several different platforms asking if the same methods would work on the Commodore Plus4 or C16. That actually inspired me to dig into the memory map for the 264 series, and I discovered that it is in fact absolutely trivial to adapt the same methods to work on its BASIC 3.5. Thus, I was able to add support for these machines with a minuscule amount of effort, and was happy to do so. If you've perceived that these screens are loading a bit slower than they did on the Commodore 64, that is not your imagination. Whereas most of the machines take slightly less than 5 seconds per screen, the 264 series seems to take a little bit more than 5 seconds. My perception is that this particular compiler is compiling BASIC into an interpreted speed code rather than into the pure machine code that is achieved from BASIC 64 and BASIC 128. With the exceptions of its different default color scheme and slightly different font, the 264 series presents RTFR exactly as does the Commodore 64. Therefore, since we've come to the end of the file, this would be an ideal time for me to press P and give you the promised demonstration of its print function. Here you can press 4 or 5 for device 4 or 5, or simply press Q to quit. I have included some error checking, so if, for example, I press number 5, where I do not have a printer configured, it will simply say device not ready, instead of crashing with the infamous device not found. I do have a virtual printer configured on device number 4, so if I press number 4, it reloads the file and immediately begins the print job. If I wish to halt the job at any time during printing, I can simply press the Q key. Printing from VIC takes much less time than printing to a physical printer because you aren't waiting for the physical printer mechanism, which on a standard Commodore printer prints at about 60 characters per second. That said, it still does take about a minute to finish the print job, so if you don't want to sit there looking at it, this is a good time to kick your emulator into warp mode. Our print job is complete, and as expected, we now have bitmap files which emulate the output of a Commodore MPS 803. If you would like more information on how to configure the virtual printers, please see my previous video on printing from VIC Commodore 64 emulator, as the information contained within it works in any emulator in VIC. For the moment, I will press the Any key, which quits back to BASIC, and it's time to move on to the VIC-20. The VIC-20 is the most underpowered machine out of all the ones that RTFR supports. It requires an 8K RAM expansion just to have enough memory to load the software. That said, it still works just fine. This was compiled with AustroComp, which seems to be some sort of a predecessor to AustroSimple for the Plus4. Much the same as the AustroSimple compiler, I believe it is using some kind of speed code rather than compiling to pure machine code. With that said, the VIC-20 does not have any problems making its 5 seconds per screen target, partly because there are less rows and columns on the screen of a VIC-20 than on that of the other machines. Much like the 264 series, the VIC-20 is another machine that is generally not on my radar, but in this case, its memory map was so similar to that of the Commodore 64 that I effectively had to do little or nothing in order to have VIC-20 support as well. The one thing I did need to do aesthetically was make sure that everything being displayed by the software, such as the status bars, fit within the more limited number of columns on the VIC-20 screen. For example, as we come to the end of the document, you notice that the final status bar is different. No longer does it offer the restart option, but only quit and print. Everything else displays exactly as you've seen it on the other machines, and in fact I wrote RTFR to work in a minimum window size of 20 columns. The reason I did that was not just for the benefit of the VIC-20, but also to make it reasonably compatible with Windows in the Commodore 128's basic version 7, which you're going to see coming up. And just to clarify, the restart option by pressing R still exists and will work if I press R right now. It simply isn't displayed on the status bar due to the room. Removing the advertising of said option really doesn't take anything away from the VIC-20 user, because all the user has to do is press Q to quit, and then type run to rerun the software, and it restarts the file directly. The reason why I coded in the restart feature was actually to work around a unique circumstance on the Commodore 128, which you're going to see next. Last and most complex is the Commodore 128. We're going to begin on the 80-column screen because what is it good for if not for text? C128 users can save keystrokes by simply typing run README, which will load RTFR and run the software using a single command. This version is compiled with BASIC 128 by Abacus Software, who also created the BASIC 64 compiler, which I used for the Commodore 64 version. The advantage of these compilers is that they will compile to actual 6502 machine code, which is not quite the same as handcrafted assembly, but still very fast. In addition, if BASIC 128 detects that it is running on the 80-column screen, it will automatically kick the computer into fast mode, thus giving the user the best possible speed. It is for these reasons that even though the 80-column screen can hold twice the amount of text of the 40-column screen, a full screen still takes only about 5 seconds. There is one very important difference with the Commodore 128 version, and that is this. When you quit, you'll notice that instead of quitting back to BASIC, we are prompted to press the any key to reset the Commodore 128. There are actually two different things going on here. Firstly, because of the memory configuration of the Commodore 128 and the way that the BASIC 128 compiler works, you cannot run a compiled application multiple times from a single load. The application needs to be reloaded from disk each time you run it. This is the primary reason for which I coded in the restart feature, so that Commodore 128 users who would like to go through the document more than once can simply restart when they get to the end, rather than having to load the software again from disk each time. You might nonetheless ask, even if typing run a second time does nothing, why not just drop the user back to BASIC instead of enforcing a reset of the computer? If you've seen my previous videos, you know that I use a speeder cartridge called the Mach 128, which is one of only 2 speeder cartridges that I'm aware of which were ever made for the Commodore 128 in 128 mode. I discovered that while using that cartridge, whatever I would attempt to load from disk next would lock up the entire computer. As it turns out, the Mach 128 inserts certain pieces of code into some lower locations of memory in the Commodore 128 which typically aren't used for anything else. Meanwhile, the basic 128 compiler, while it does tend to leave alone any of the lower memory locations that are assigned to a specific purpose, does also use some of the same lower memory locations which typically aren't used by anything else. So it isn't that my code or the Mach 128 code or the basic 128 code are independently doing anything wrong per se, but nonetheless, rather than leave the computer in an inconsistent state, since you cannot run the software multiple times off a single load anyhow, that I would simply have the user press the any key upon exit to enforce a reset, which then brings you back to a clean slate functional system. On the Commodore 128's 40-column screen, I'm going to end off with something a little bit wacky. If I were to simply run the software now, it would look identical to what you've already seen on two other computers, save the fact that it would have a slightly different color scheme and font. However, I did already mention that RTFR is compatible with Windows, and it is in BASIC version 7.0 on the Commodore 128. I'm going to give it a window of the minimum size that it will accept, which is 20 columns by 10 rows. If I now run README, you're going to see something that looks a little bit different. And there you have it. While it may not be entirely useful, or perhaps even sensible, you can give RTFR a window as small as 20 by 10, and it will simply adapt, just like the Borg. If you found this interesting or entertaining, please like and subscribe to Basic Bytes for more. Also, be sure to head over to my file share at files.basicbytes.ca and download your very own copy of the README text file reader, which you can, of course, redistribute freely as you wish. Feedback is welcomed in the comments, and in the unlikely event that you find any reproducible bugs in the software, I would certainly like to know about those as well. Thank you for watching.